Let's look at Ferrari's method of solving quartic equations. Let's say the function, the equation is fnx equal to, actually I should write f4x is equal to x to the power of 4 plus ax cubed plus bx square plus cx plus d equal to 0. Now, let's reduce this. So x is equal to y minus, and we will reduce it by a by 4. So how did this a by 4 come? Minus a1 by a naught, n a naught. Here a1 is a, so minus a by n is 4 degree, right? And a naught is 1. So minus a by, okay. So now let's do it the long way, right? But as you keep doing it, it will become much more clearer. So y minus a by 4 to the power of 4 plus a times y minus a by 4 cube plus b times y minus a by 4 square plus c times y minus a by 4 plus d equal to 0. Okay? Now let's expand this. So we get y to the power of 4 minus 4 a by 4 times y cube plus 6. I'm doing the binomial expansion, so I know the coefficients 1, 4, 6, 4, 1. So this will become a square by 16 y square plus, no, again now minus 4 a cube by 64 cube. 4 cube is 64 and y plus 1, right? So a 4 by 64 fours 256, and now the second term would be a times y cube minus 3a by 4 y square plus 3 times a square by 16 y minus a cube by 64 plus. Okay, now next term will be b times y square minus 2 times a by 4 y plus a square by 60 plus cy minus ac by 4 plus d equal to 0. Let's open up these brackets. Okay, so we have y4 minus 4 and 4 gets cancelled, ay cube plus, and this becomes 2 3s 2 8s. So 3 by 8 a square y square minus 4 1s 4 16s. Okay, so we are left with a cube by 16y plus a4 by 256 plus ay cube minus 3a square by 4y square plus 3 by 16 a square. No, now it will become a cube y minus a to the power of 4 by 64. Next will be by square minus, this 2 will cancel, so this will become ab by 2y plus a square b by 16, then plus cy minus ac by 4 plus d equal to 0. So we have expanded it. Now let's see what's happened. what's happening here? Ay cube, they cancel out. So that means our cubic term is gone now. We are left with y4 plus. Now what we'll do is we will group them together. So y4, y cube is gone. So we have to group now y square. So 3 by 8a square minus 3a square by 4 plus b y square plus. Now we'll group y. This is minus a cube by 16 plus 3a cube by 16 plus c minus ay by 2. Minus ay by 2, or rather minus a by 2. Actually, this will be ab by 2. Okay, so that is this. Now the next will be without any y's. So plus a4 by 256 minus a4 by 64 plus a square b by 16 minus ac by 4 plus b equal to 0. Now this whole thing we can take it as together. So we have y4, y square, y and the constant. Now y4 plus, let's combine all of these, or rather these two. So we have 3a square minus 6a square. So we get minus 3a square by 8 plus b y square plus, again we can do the same thing here, 2a cube by 16, and here actually we can simplify to a cube by 8 plus c minus ab by y plus, again here these two we can take care. So this becomes a4 minus 64 times 4 is 256. So a4 minus 4a4 is minus 3a4 by 256 plus a square b by 16 minus ac by 4 plus b is equal to 0. So now let p is equal to b minus 3a square by 8 in this one. Q is equal to a cube by 8 plus c minus ab by 2. This. And then r is equal to d minus, we are taking this first to avoid a negative sign in the beginning, ac by 4 plus a square b by 16 minus 3a4 by 256. This one I just rearranged. Okay, so if we do these substitutions, our equation will become y4 plus py square. Yes, this equation I'm substituting pqr plus py square plus qy minus r equal to 0. Now what I'll do is I will make it as I convert this into a perfect square. So if I say y square, I can do that, plus 2p y square plus p square. So this is actually become a perfect square now, but I have added some terms, so I have to remove them. So I've added one py square, so minus py square, and I've added p square, so minus p square is equal to, and let's take this qy and r to the other side, so minus qy plus r. Actually this is plus, so that means this is going to be minus qy minus r. Now this can be written as y square plus p the whole square. And let's take these to the other side. So here I end up with py square minus qy plus p square minus r. See, here our objective is to have perfect squares on both the sides of the equality, right? Not only that, but perfect square means we will end up with a term here and an expression here and an expression on this side, both of which should be perfect squares. Not only that, we should, when we expand it, we should end up with 5 terms. That is x to the power of 4 plus ax cube plus, we should end up with totally 5. So that means here we have only 3, right? So we should end up with 5. So what we'll do is, and this will become a perfect square. This is quadratic. So here you will have a perfect square with 2 terms. So that means here we should have a perfect square with 3 terms. So the 3 plus 2 is 5. So for that purpose, we will say y square plus p plus, and here we will add one term lambda and make it a square. So which means what have we done? We have added some additional terms to this side. What are the terms we have added? We have added lambda square and we have added 2 y square plus p lambda. Now what I would suggest is you expand this and see whether this is correct or not. When you expand this, these two will get cancelled with this and you'll be left with y square plus p the whole square is equal to py square minus qy plus p square minus r. Okay. Now let's take these two to the other side. So y square plus p plus lambda whole square is equal to, what will we have? We will have py square minus qy plus p square minus r plus lambda square plus 2y square plus p lambda. Let's group them. So let us say py square minus qy plus p square minus r plus lambda square plus 2y square lambda plus 2p lambda. So now let's group them. We have p plus 2 lambda y square. Okay. Then we have minus q. Do we have y? No. So minus qy. Then we have plus and the remaining. So we have p square minus r plus lambda square plus 2p lambda. Okay. Let's make this proper. Okay. So we have an equation, a quadratic equation in y. Okay. And we want this to be a perfect square. And this will, a quadratic will always be looking like this. So you will have, let's say, sy plus t square. Something like this will come, which when you expand, you will get this. So to arrive at this perfect square, what is required? A quadratic equation is a perfect square when, b square minus 4ac is equal to 0. That is, your delta discriminant is equal to 0. So that it disappears and you are left with just a repetitive root. So which means basically a square. So let's actually figure out what delta is. B square minus 4ac. Now here b square is, b is minus q. So this will become q square minus 4 times p plus 2 lambda times the constant term, this entire thing. So p square minus r plus lambda square plus 2p lambda, this entire thing. Now let's open up this. So q square minus 4p plus 8 lambda square minus r plus lambda square plus 2p lambda a. Now let's multiply these two. We get q square minus 4p cube. Then we have 4pr plus 4p lambda square plus 8p square lambda plus 8p square lambda minus 8r plus 8 lambda cube plus 16 p lambda square. Okay. Now let's open up this bracket. So we get q square minus 4p cube plus 4pr minus 4p lambda square minus 8p square lambda minus 8p square lambda minus 8 plus 8r minus 8 lambda cube minus 16p lambda square. Okay, remember all these should be equal to 0. So here we have to keep on writing equal to 0. So which means we have to say implies. Okay, now this is a okay. Let's see whether we can simplify it further. Uh, q square remains as it is. Do we have p cube only? No, we don't have p cube. So let's say 4p cube. Okay. Do we have pr? pr is not that. So 4pr minus 4p lambda square. 16p lambda square. Okay, so this and this minus 20 lambda square. Then we have p square lambda. P square lambda. So minus 16 p square lambda. Okay, then we have plus 8r minus 8 lambda cube equal to 0, okay, which implies now let's arrange them based on lambda. So we have minus 8 lambda cube. Then we require square, so 20 lambda square. Then we need lambda. Do we have any other lambda square? No. What about lambda? Okay, here I made a mistake here. When multiplying 8 lambda into minus r, I forgot to write lambda. So this is actually minus 8 r lambda, which becomes plus 8 r lambda. This becomes 8 r lambda. So here we have lambda, right? So we will have plus 8r minus 16p square lambda. Yes. So we have got minus 8 lambda cube minus 20 lambda square. Lambda is done. So now the constant. So we will have plus q square minus 4p cube plus 4pr and what else? That's all equal to 0. Again, we can take out minus out and take it to the other side, so it disappears. So 8 lambda cube plus 20 lambda square minus 8r minus 16p square lambda plus, and this whole thing we can put it in a bracket. So q square, so sign has to change. So let's bring this front minus q square minus 4pr equal to 0. Okay, minus plus minus plus plus minus plus minus minus plus plus minus. Okay, so This has to be solved now. So we have a cubic equation in lambda, and we have already seen how to solve a cubic equation. Yes. So find a value of lambda such that, remember the delta that we were talking of, delta is equal to 0. Delta of not this, but of the quadratic equation. Okay. So we can use any method to solve this cubic equation. So delta becomes 0, which means y square plus p plus lambda square is equal to sy plus t square. When we find that solve this equation, we'll get the root. We will naturally choose a real root and substitute it there, and we will end up with a perfect square. Now, once we have this perfect square, what we can do is bring it to the other side. So y square plus p plus lambda square minus sy plus t square equal to 0. So this is like your a square minus b square. So this can be written as a plus b, a minus b. So which means we can write it as y square plus p plus lambda plus s plus t s y, and we can write it as y square plus p plus lambda minus sy minus t equal to 0. Now let's take it one further step. Okay, so this can be written as y square plus sy plus p plus t plus lambda times y square plus, no, not plus, minus sy plus p plus lambda minus t equal to 0. So this is a quadratic equation. This is a quadratic equation, right? So we can use the any method, factorization or straightforward. We can use quadratic formula to arrive at two roots of this quadratic, two values of y. Similarly, quadratic, two values of, okay, which means since we have four values of y, remember we did initially when we were reducing the equation, we said x is equal to y minus a by 4. Yes. So what we do is we have got the y, we know the a, so we get four values of x. So therefore roots are same. What we'll do is in the next session we will solve some problems based on this. That's it for now. Bye.